Hi guys, welcome to another session. This session we are going to learn about how to build a web application in AWS. So we are using the following services: AWS Amplify, AWS Lambda, AWS API Gateway, DynamoDB and IAM. These are all the prerequisites required. Some basic knowledge on AWS. You should have an AWS account and basic coding. The steps to be followed. The step 1 is hosting a web page. Step 2 is writing a functionality. Step 3 is invoking that functionality. And step 4 is store the result. Finally, we should handle the permissions. For this, hosting a web page, we use AWS Amplify. For writing the functionality, we use AWS Lambda. To invoke the functionality return, we use AWS API Gateway. To store the result, we use AWS DynamoDB. And finally, to handle permissions, we use AWS IAM. This is the architecture we use in our application. As I said, AWS Amplify is used to host or build a web application. Our web page is so simple and we create a HTML page using text editor and we use Amplify to deploy and host that web page. Next is AWS Lambda. AWS Lambda runs the code upon some trigger. The code will present there simply and runs whenever it is required. The next is API Gateway. It is used to build a HTTP, REST API or WebSocket API. Anyway, we are not going to have an AWS console and run it. Instead, we use an endpoint or a URL to trigger the function. Then DynamoDB. It is a key value paired NoSQL database. And finally, we have AWS IAM. Anyway, the Lambda function need permission to write the result in DynamoDB. Yes, so we need to set the IAM for that. This is our working model. The input is in Celsius form. We are giving 100 as Celsius value and we are converting this Celsius into Fahrenheit and Kelvin. Click on convert. Yeah, we are getting the equivalent of 100 Celsius, which is 212 as Fahrenheit, and the Kelvin value is 373.15. This is my AWS account section. The first step is to host a web application using AWS Amplify. So click on AWS Amplify, click Get Started, choose Host Your Web App option and choose Deploy Without Git Provider option and click on Continue. Name your application. Our application is Temperature Converter. So I name it as TempCon. Leave environment name as DEV. Choose a drag and drop method. Choose files. So here we need to have the index.html file in zip format. So click on choose files, move to the location where you have your application and make the index.html file compressive in zip format. Choose index.zip and click open. Then click save and deploy. Yes, wait for a while. Yes, the deployment is successful. The next step is to write a function using Lambda. Click on Lambda. Click create a function. Name your function. Choose the runtime. I choose Python 3.11, which is the latest one. Click create function. The function has been created. Move downwards. So this is the updated function for our application. Here the input Celsius is converted to Fahrenheit, and the next line the input Celsius is converted into Kelvin value. Here the status code 200 denotes the successful operation. Click on deploy. Click configure test event. Name your test event. Choose private. So we are going to test our function. So we are going to test our function by giving the input 100 Celsius. Click test. Yes, the test is success. The status code we obtained is 200. It means success. And the output we obtained is 212 for Fahrenheit and 373 for Kelvin. Our next step is to create an API gateway. Click on API gateway. Choose the REST API. And choose new API. Name your API. And click create API. Ensure the resources option is chosen and click create method. Choose the post option. Associate the Lambda function. Temcon is our Lambda function and click save. So here mentioning about give API gateway permission to invoke your Lambda function. Yes, click OK. Click actions. Choose enable CARS. CARS stands for cross origin resource sharing. It allows the application to access the resources in different origin or domain. Click enable CARS and click yes, replacing existing values. Click deploy API. Choose the deployment stage, name your stage and click deploy. This is the invoking URL. So copy it, save it somewhere locally. Click resources and choose post method. Now we are about to test our application. Click on test. give the input, then click test. So we got 200 as status. The next step is to create a DynamoDB instance. Choose DynamoDB, click create table, name your table, here mention the partition key. We have two indexes. First one to store the Fahrenheit value, the next one is to store Kelvin value. Click create table, the table status is active, so click on the table, move to actions, then click create index. We need to have one more index now for storing Kelvin value. Mention K value and click create index. Yes, the table is created with the preferred indexes values. Now move to Lambda section, click configuration tab, click permissions, click on the role temp con. Now we need to set IAM role. Click add permissions and choose create inline policy. And choose JSON format. JSON format is in local section. Make a copy of it, paste over here. You need to specify the resource name, ARN, Amazon resource name. So go and get it from DynamoDB. So this is the role, that means IAM role for writing the result in DynamoDB. Get the ARN from table section. Click on temp, then click additional info and copy the ARN here. Move to the policy area and paste it over here. Click next. Name your policy. And click create policy. Yes, the policy has been created. Now move to the code tab. Update the Lambda function, because the Lambda function what we have now is not writing any values in the DynamoDB table, right? So we need to update the code. So this is the updated code for Lambda function. Here we need JSON, we need Boto3. Boto3 is a Python SDK for AWS, and we are using the resource DynamoDB where we have created a table. We need to choose the table. The table name is, make sure the table name is right. Temp table is the table name. So come over here, TABLE, this is the exact name, and now stores the current time. The lambda handler, as I said, we are having Fahrenheit value and we are having Kelvin value over here. The put item method stores the item in the corresponding index values. So here f value stores the f is nothing but holds the Fahrenheit value and k holds the Kelvin value along with the time. So we are putting this particular item in our table. Once it is successful, it returns 200. We are about to test it now. Deploy it before testing and click test. We are getting 200 status code, means the test is successful. Now move to AWS Amplify. Choose the updated index.html file. Before that, we need to update the index.html file. So move to download section, and this is the updated index.html file. I have opened it in Notepad++. This is the head portion. We have HTML and CSS along with script tag. So here you need to specify the API gateway. Yes, this is the API gateway invoking URL. We need to specify it here. Save it. So in this file, h1 tag temperature converter is displayed. We have Celsius label and we get an input text. On click event, call API routine is called along with the Celsius value. So it moves to the script tag. Once it is successful, it fetches the data in the corresponding link and JSON alert is displayed. Now run the application. Click on the link. The application is running. Give input for Celsius. Click on convert. The equivalent value for the Celsius is 212 as Fahrenheit and 373 in Kelvin. Okay. Click on OK. Now check the entries in table. Go to your table. Click on it. Export table items. Yes, we are updating it. So the result is stored in the table. The application is successfully running.